Let's take a look. It's chapter 4, and you probably recognize this question. Does anybody recognize this? I think this was on the quiz, wasn't it? It wasn't on the quiz? Does anybody have the quiz in front of them? No? Nobody? That's all right. I think it was. I think it was. So you have to identify the triangles, right? Identify them by their, watch this, let me write this down, by their angles and by their sides, right? So let me just jot that down. So we're going to classify these triangles by their angles and by their sides. Did you find the quiz? Is it on there? Okay. All right, so classify it by its angles and by its sides. So let's take a look at this triangle right here, ABD. Here's A, here's B, here's D. Now we have to classify it, first of all, by its angles. Now they don't really tell you anything about the angles in this triangle, but you can kind of look at it and tell. They do tell you all three sides are equal. What does that tell you? If all three sides are equal, what do we know about all three angles? They're equal angular. That's right, equiangular. So that means all three angles are equal to each other. So if we classify it by the angles, we're going to call it equiangular. All right? There's something else you could call it too if you wanted to. I mean, you could stop with equiangular for the angles and you'd be okay. But what else do you think you could call this triangle? Look at the angles in here. What's that? Well, by the angles again. There's another name. Well, it's not isosceles because that's sides. Say it. It's acute, right? Look at all three of these angles right here. All three of these angles. You're going to be waiting the rest of the class. Are you still looking for your book?
Yeah, that's what's going to ask.
Well, what am I supposed to do? No, I'm not going to say it all over again. It's here it is right there. It's either equiangular or acute, either one of those, it doesn't matter, or equilateral or isosceles, either one of those. All right, let's go to triangle ABC. ABC. Now, I gave this on the quiz because I think I remember a lot of people on the quiz doing this. It's ABC, all right? All right, so look at the angles. Look at the angles on triangle ABC. This is acute, that's what? No? There's a big arc or right angle symbol there, and this is acute down here. Now we don't call it an acute triangle if only two are equal. Or I'm sorry, if two are acute, you look for the biggest angle, and that's a right angle, isn't it? That's a right angle, so we call it a right triangle, and that's the only thing you can call it. You cannot call it an acute triangle. Just because there's acute angles in it doesn't mean it's an acute triangle. It's only an acute triangle if all three of the angles are acute. Everybody understand that? What about by its sides? Again, look at ABC. ABC. It's that whole big giant triangle right here. Are two of the sides equal? Now this one has one. This one has one tick mark. This one right here, it doesn't just have one tick mark, does it? It's got one here and one here, which means this is actually twice as big as this, isn't it? So those two sides are not equal. What about this side right here? Any indication that this side is equal to this side?
Yeah, two.
Well, it's got two just on this little part of it, not the whole entire thing. So we have no idea, though, do we? We have no idea if this side is equal to this side, which is equal to this side. We don't know. So we don't know any of the sides are equal to each other. So what do we call it? Carol, you said it. It's scalene. All right? So it's scalene. Scalene means none of the sides are equal to each other. All right? So it's a right triangle and it's scalene. This is by its angles. This is by its sides. Let's look at this one. Nope, you can't say obtuse on this because it's a right angle. It can't be obtuse and right at the same time. Okay? Look at this. Triangle BDC. BDC is from here to here to here. It's that triangle right there. Everybody see that? So that's triangle BDC. Now let's find out by its angles. Yeah, that's right. This one is obtuse because look at that angle right there. That's an obtuse angle in that triangle, isn't it? So even if you just have one obtuse angle, that's an obtuse triangle. So we say it's obtuse. What about the sides of this triangle? Well, it's isosceles, right? Because look, you've got one tick mark here and you've got one tick mark there. That means two of the sides are equal to each other on this triangle, BDC. If two of the sides are equal to each other, we call it isosceles. There's no or for this. All right? It can only be obtuse by its angles, and it can only be isosceles. Make sense? You got to know these words. I'm not going to put this in a list of words for you. You have to know what these words are. You got to know it's equiangular. You got to know acute, equilateral, right, scalene, obtuse, isosceles. You got to know those words. You got to be able to come up with them off the top of your head. Now, I will give you some stuff on the midterm. Didn't I tell you that? I'll give you some formulas. If you need to do midpoint, I'll tell you what the midpoint is. If you need to do slope, I'll tell you what the slope is. I'd probably even tell you what the slope-intercept form and the point-slope form is. I'll tell you all that stuff. You just have to know how to use them. So don't sit and try to memorize a whole bunch of stuff. But this is something that you should know. You should know the meaning of these words right here. That will not be on that list of stuff that I give you for the midterm. All right? Let's do another one. Let's look at number 4. Let's do this in red. Number 4. Well, it's number 4 on my test. I didn't give you a test because you haven't had the test on this yet. But on my paper, it's number 4. Write this down, though. It's triangle FGH. So there's my triangle FGH, and they tell you that it's equilateral. You might remember this from your quiz, because I think this was exactly on the quiz. So this triangle is equilateral, and look what they tell you. They tell you that FG is equal to x plus 5. They tell you that GH is 3x minus 9. And they tell you that FH is 2x minus 2. Okay, so look what they give you. They give you all 3 sides. They give you all 3 sides of this triangle. And it said the triangle's equilateral, right? Well, what do they ask you to find? Well, they ask you to find x, first of all, but they also ask you to find something else, which is the measures of the sides of the triangle. So you're actually finding 4 things there. You're finding 3 sides and you're finding x. That's 4 different things. First thing we're going to do is solve for x. So let's take a look. This FG is one of the sides of my triangle. GH is one of the sides of my triangle right here. And FH, right here, that's also a side of my triangle. And what's true about all 3 sides of my triangle here? They're equal to each other because it says it's equilateral. Now look, here's something that some people did. I don't remember who did it. I don't really notice who does these things. I just remember it when I was grading it. That said, some people put all 3 of these things equal to each other and tried to solve for x. You really can't do that. Okay, you can't set 3 things equal to each other. You can only set 2 things equal to each other. So does it matter which of these 2 that you set equal to each other? It doesn't matter because they're all 3 exactly the same, right? So it doesn't matter. But you only pick 2 of them. Just pick 2 of them set equal to each other. Don't pick all 3, because I saw several people do that. Okay, not just one. I saw several people do that. So let's pick 2 of these to set equal. What do you think the easiest 2 would be? Yeah, probably FG and FH. I'd probably agree with that. So I'm going to put the 2x minus 2 first, and then the x plus 5 next. Now you could have put the 3x minus 9 in one of these right here. Don't put all 3 of them next to each other, okay? Don't put equals 3x minus 9 and then try to solve for x. You can't really do that. You can only have 2 sides, a left side and a right side, no middle. Everybody got that? So now we solve for this. Yeah, it's pretty easy. Subtract x from both sides, add a 2 to both sides. That cancels. 2x minus x is x, and that's 7. So that's part of your answer, but it's only 1/4 of your final answer, isn't it? It also says to find what? The measures of the what? Of the sides. So what are we going to do to find what the sides are equal to? Plug it in. That's right. Plug it in. Take that 7 and put it in for x. So let's do that. 7 plus 5 is 12. So FG is 12. Now you could, if you want to, take this and plug it into this. But what do we say about this triangle? It's equilateral. So do I even have to worry about plugging them into the other ones? No, because if this is 12, what's this have to be? It's got to be 12. What's this have to be? It's got to be 12. And that saves you a little bit of math. It wouldn't take you that long to figure it out, but what's that? Do you? Okay, yeah, this was exactly letter for letter, word for word from the quiz. Okay? There you go. Now, there is another problem on this particular test that's like that, but I'll just stop right there with that type of problem. All right. All right. Let's pause this. I'll draw another picture, and we're going to solve for missing angle. All right. Here you go. Let's take a look at this. This basically centers around that fact that how many degrees are in a triangle if you add them all up? 180, right? So this uses that whole idea. So let's take a look. Let's solve for angle 1 first. Now there's a quick and easy way to solve for angle 1 if you remember one of our theorems. Yeah, do you remember that? Do you remember the exterior angle and the remote interior angle? Anybody remember that one? Okay, this is the exterior angle to these two angles, isn't it? Look at this triangle. Do you see it? I extended it out. This is an exterior angle. What's the exterior angle equal to? The sum of the remote interior angles. Now, you don't have to know those words, remote interior angle, but you just have to know what it's equal to. So this angle 1 is equal to what? Just 58 plus 39. So it's very simple math to figure that out. All right, so that's a 17, that's an 8, that's a 9. So that's a 97 degrees. All right? And now we got to find the rest of them. What's the next easiest one to find probably? Probably 2, all right? So how would I find angle 2? Take it away from 180, exactly right. Take 97 away from 180. So you've got 180 minus 97. All right, then you just work that out. That's a 3. That's a, what, an 8? So that's 83 degrees right there. Now look, it may not look like it's drawn to scale. That looks obtuse, doesn't it? Angle 2. And that's 83 degrees. But don't just go by the looks of it. Go by the numbers, okay? You've got to go by the... Oh, it is... No, that's right. Did I do that right? Yeah. All right, so it may not look like it's 83 degrees, but you got to go by the numbers. I told my last class this. When you take the SAT, you know, the test to get into college and stuff, I remember back in the day when I used to teach SAT classes that they had some problems on there. It had some geometry stuff. They give you a picture very similar to this, and they would say, it says like note or something like that, and then it said figure not necessarily drawn to scale. All right, it says not necessarily drawn to scale, which means just because this looks like an obtuse angle doesn't necessarily mean it's actually greater than 90. Does that make sense? You just go by the numbers that they give you. You all right with that? Okay, so that's helpful. So when you see that, when you take the SAT, you remember back to this and like, oh yeah, Mr. Hamrick said it may not look like those are equal or this is obtuse or this is acute, but I have to go just by the numbers, okay? All right, let's keep going. Now we do angle 3. Now, you could do it a couple different ways. I think this is the easiest way. Do you remember that exterior angle thing we did about 10 seconds ago? Look, 97 is now the exterior angle to these two. Everybody see that? Here's my triangle. Extend this side out. There's my exterior angle. These are my remote interior angles. Now, I would just add these up. Problem is, I don't know what this is, do I? But I do know the exterior. So how do I find this? These two add up to be 97. So how do I find this? That's right. You take 35 away from 97. Very good. So it's 97 minus 35. That's a 2, that's a 6, so there you go. That angle right there is 62 degrees. And that's how you do it. It's not so bad, is it? It's really nice. Now, you didn't really have to know that exterior angle thing, but it makes it a lot easier. That's why we learned the theorem, because it makes it way, way easier to do that. All right, let's do another one. I should have saved all these pictures from the other class because I drew all these in the other class, and I got to draw them from scratch again. Yeah, I'll pause it. Thanks. All right, here we go. Here's our picture, but if that's all I had right there, you wouldn't be able to say anything. You have no idea what angle A is equal to over here, or if it's even equal to anything over here. You have no idea. So they have to tell you this. They give you this. They call this the congruent statement. You remember talking about that? So ABCD is congruent to polygon. It's not a triangle, so you don't put triangle there. PQRS. PQRS. Now this is really important. I think a lot of people just blow this off when they see this. They're like, it's just, it's just what he writes on there, just to, people think it's just a, a repeat of what you've got right here. But it's very, very important. Okay, it's important because it tells you exactly which angles are equal to each other. All right, you wouldn't be able to tell just by looking at the pictures. You can't just look at it and tell. So if you look at this, let's start with angle A. Just by looking at this congruent statement, even if I didn't have those pictures on there at all, looking at angle A, what is equal to angle A over here in this other polygon? Angle P. All right, because they're first, right? They got to match up. They got to correspond to each other. So angle A and angle P are equal to each other. Well, that helps us out here, doesn't it? Look at this. Angle A equals angle P. And so if I want to solve for x, that's what we're trying to do. We're trying to solve for x and y. I didn't write that down, but that's what we're trying to do. if I have to solve for x, what do I do with those two things? Set them equal to each other. That's right. Equal them. I guess you could use that as a verb. Equal them. All right, but yeah, set them equal to each other. And then you just do the math. All right, so that's 2x equals 96. Divide by 2, and I think that's 48, isn't it? Yep, 48. That's all there is to that. It's not hard. It's not really difficult, but you got to make sure you use the right number. Some people would look at this and say, oh, this is in the top left corner, and this is on the top left corner, so those two are equal to each other. Okay, but they're not, because this is what they give you in your congruent statement. So the first one equals the first one. The second one equals the second one, and so on. Okay? And that's the only angle they give you, or they ask for. What else do they ask for? Solve for... Well, we solve for x, so now we have to solve for y. Yeah. So let's take a look at the thing with the y in it. It's this thing right here. Now, you got to decide, is this equal to 12 or is it equal to 10? Okay, and how do you know it's 12? Because of this. Watch. This is DC, isn't it? Right there. So come over here. Which one is equal to DC or CD over here? RS is. So this is DC is equal to RS. So is it equal to 10 or 12? It's equal to 12. That's the way you want to. That's the way you want to do it. You don't want to just look at it and say, well, that one looks longer than that one. No, sometimes they draw it kind of weird and they don't make it look exactly like it's supposed to. So you go by the information that you definitely know. You know those are equal to each other. So we set them equal to each other. If there's anything you learn in here at all, it's solving these algebra equations, isn't it? We've done a ton of these things. I mean, you probably had no clue we do this much algebra in a geometry class, did you? But we do. Okay, yeah, you did it last year, exactly right. So that should help you out. And you're doing it this year, and next year you guys are going to be taking Algebra 2, and you're going to be doing a ton of this stuff, but even more difficult. What's that?
Substitution.
Yeah, you'll do substitutions, eliminations, you'll do, yeah, all that kind of stuff. And you should have done a lot of that in Algebra 1, but you'll definitely do it in Algebra 2. All right, divide both sides by 3, so y is 5, and that's your answer. That's how you do it. All right, so what's the key to this? The key is looking at that congruent statement and knowing which things are equal to each other. Everybody got that? Okay. All right, we're rolling right along. Let's do a little proof. Let's do, I did number 11 in the other class. Let's do number 12 in here. And let me draw it out. Okay, here's our picture for our proof. Now watch how easy this is. I got some moans and groans from my other class when I said, okay, I'm going to put a couple proofs on the midterm. Watch how easy the proof is. This is all I'm going to ask you to do when it comes to the midterm. And again, for you guys that are leaving, if you have to do proofs, they're not going to let you get away with this quite this easy. You're going to have to back up your reasons or your statements with reasons and things like that. But I've been helping you out a little bit because we've talked about why these things are true. So anyway, let's just mark this stuff. Now, the reason I made this in red, because this is what I want on the test. Everything that I do in red is going to be on the test. Everybody got that? So you've got to draw out the picture and mark it all up. This is how we mark it all up. Angle N equals angle L. So we mark that. This is what I'm looking for on the test. I'm looking for those little arcs right there. Okay? And then it says JK equals MK. I think they might put a line segment over top of it. So JK, how do I show them equal to each other? Just put little tick marks here. Okay? That's all they tell you from the given. But it's up to us now to look at the picture and decide, is there anything else that I can say about this picture, John?
Angle MKL and JKL.
Very good. All right, you said those perfectly. So look, these two angles right here are equal to each other. Now, what's the reason? If I ask you to back it up, what would the reason be for these two angles being equal to each other? Vertical angles are equal. Exactly right. Okay. Now, is that enough to say that these two triangles are congruent now? It's not?
Yes, I didn't. Yeah.
Well, that's what I'm asking you. But do we have enough information? I should say that. Do we have enough information to say these triangles are congruent? Absolutely. And what is the reason? Okay, Justin. Angle, angle, side. Okay. So everything that I wrote in red, all right, with the exception of those little things right there, this is what I want on the test. You don't have to rewrite the given. You don't have to rewrite the proof. Okay, you've already got that on your test. All right, so you don't have to worry about that. Draw the picture, though. because you have to mark the picture, right? And I don't want you to mark the picture that's on the front of the test. I want you to redraw the picture on your answer sheet. Then you mark all the angles and sides that you know are equal to each other. Then you determine why are they congruent, angle, angle, side. That's all you have to do for a proof in here. Okay, I'm making it really easy for you. All right, let's do another one. Yeah, we got time to do this next one. Okay, here's our picture, and this is what we want to solve for. Everything in yellow is what we want to solve for. We kind of did this earlier. Remember we did those triangles, found the missing angles and that kind of thing, that exterior angle stuff. This is kind of the same thing. You need to know that the three angles add up to 180 degrees. That's really going to help you out here. All right. So we want to find angle 1. Well, look at this triangle that angle 1's a part of. What kind of a triangle is this by its sides? What kind of a triangle is it? Okay, it's not a right triangle. That's 92. It's isosceles, right? Because this side and this side are equal to each other. Now, do you remember something? If two sides of a triangle are equal to each other, what's true about the opposite angles? They're equal to each other as well. So what does that mean? That means angle 1 is equal to what? Angle 2. That's very important right there. Okay, that's our first step, is to understand if these two sides are equal, the opposite angles are equal as well. All right, now let's think about this. If this is 92 degrees, how do I find the two missing? Take from 180. That's right. So let's go 180 minus 92. All right, and that's an 8, and that's an 8. Does that mean angle 1 is 88 degrees? No, it means these two. That's right. Then these two add up to be 88 degrees. Now they're both exactly the same. So what are both of these angles? 44 degrees, right? So divided by 2, that's 44, and that's 44. That was the hardest part of this whole thing. The rest of it is pretty easy, I think, because one thing is simple, and then the other one is almost exactly what we just did right here. So let's take a look at this angle 3 right here. Well, we already know this is 44, so what would you do? Yeah, these two add up to 180, so you could do what? 180 minus 44. There's something else you could have done as well. This is an exterior angle to this triangle, isn't it? So if you wanted to, if you didn't like subtraction, you could do addition, couldn't you? And what would your addition be? The remote interior angles, remember that? See exterior angles? You could go 44 and 92, couldn't you? If you wanted to. Doesn't make any difference, right? Let's just do the subtraction. That was a little easier to see, though, wasn't it? Makes a straight line. We're used to seeing that now. So that's a 7, that's a 10, it's a 6, and that's a 3, and that's a 1. So that'd be 136 degrees. It's supposed to be a degree symbol. There we go. All right, we good so far? All right, let's find angle 4. Now again, look at angle 4. It's part of this triangle right here. Well, it's an obtuse triangle, but it's also what? It's also isosceles, isn't it? All right, we can do the same exact thing as we did on the first one. All right, so let's see what we did. We go 180 minus what? 136, and that gives you 44 degrees. All right, does that mean this is 44 degrees? No, it means this one plus this one right there. I'll put 3 arcs here. 3 arcs here. It means these two add up to 44. They're both exactly the same. So what do I do with that 44? Divided by 2, and that equals 22, and that's that angle right there, 22 degrees. All right. Looks easy when I do it, doesn't it? But what you have to do is you got to practice these things, okay? You've got to look at these things. You got to practice, and that's pretty much it for Chapter 4. You're probably almost ready to take the whole Chapter 4 test now anyway, aren't you? Okay, let's do it. Yeah. No. It'll be on, so you'll have several problems. I don't know exactly how many. You might have 5, 6, 7, 8, 9, 10. No more than 10. Absolutely no more than 10 from Chapter 4. Okay? From any chapter, I think. But definitely not from Chapter 4. All right? The midterm in here is when? It's Thursday, first class period. Oh, that's right, because Friday we don't have any. It's Wednesday, right? It's the day before that. It's Wednesday, and it's the morning session, or the early session, I should say. They're both morning. All right, please be ready for it. Please be studied up and do well on it.